function machines. In the previous lesson, you used equations relating two variables like y equals 3 times 2 to the x to make graphs and find information. Today, we'll look more closely at how equations that relate two variables help establish a function between the variables. We'll also learn a new notation to help represent these functions. So essentially, the new notation today is going to look like this. If we have an equation that says y equals 2x plus 5, we're just going to write it in, it's known as function notation, and f of x takes the place of the y. So really you can see it's very similar, but now y is going to equal f of x, or maybe we name it g of x instead. So we could say g of x equals 2x plus 5. A question might be, well, why would you need to do this? Like, I'm happy with y. I have kids every year that complain, like, look, I'm used to y, I like y, I don't want to change it to f of x and g of x. And one of the things I would say is this. Let's go ahead and make this more reasonable, where I have something that looks like this, where they're two distinctly different equations. If I said, hey, plug 2 into that equation, well, now you don't know which one I'm talking about. Do I plug 2 in over here and get 9, or do I plug 2 in over here and get 4? You don't know that. But these sort of act as a name, like f of x and g of x. So then this is the next part of the notation that I wanted to discuss. I might say something like this. I might say, all right, well, it's g of 2. Oh, my goodness. Look at what a mess I am. All right, so g of 2. So you can see in this example, 2 replaces the x. And I'm obviously not talking about the f of x. I'm obviously talking about g of x. And what I'm saying is wherever you see x over here, replace that x with a 2. Contrarily, if I put like f of negative 1, you would go over here and you would say, all right, well, I'm going to take out that x and I'm going to replace it with a negative 1. And negative 2 plus 5 equals 3. So that's just a little introduction into the notation that you're going to see today. I'm going to go through it fairly quickly now, but I just want you to be aware that that's sort of where we're headed to with this. So are we related? Examine the table of input x and output y. So we input the x variable, we output the y variable. Is there a relationship between the input and the output variables? Well, it looks like it. Every time my x goes up 1, it looks like my y goes up 3, which is important because slope is the change in y over the change in x. Again, that's the delta sign. It means change. I don't actually care what y is. I just care how much y changed by, and it changed by 3. And again, I don't care what x is. I just care how much it changed by, and it changed by 1. So 3 divided by 1 is 3, so I have a slope of 3. And my y-intercept is when x is 0, what is y equal? It's negative 1. So I would say it's y equals 3x minus 1 would be my equation of this. So function machines. A function works like a machine as shown in the diagram below. A function is given a name that can be a letter such as f or g, which we've already talked about. The function notation f of x represents the output where x is processed by the machine. Note, f of x is read f of x, right? That in parentheses means of x. When x is put into the machine, f of x, the value of a function for a specific x value comes out. In this notation, f of x replaces y. So for example, y equals 3x minus 1 would be written as f of x equals 3x minus 1. Again, we've talked about all this, so hopefully you're okay with that. Are equivalent ways to write the same function. Numbers are put into the function machine, in this case, f of x equals 3x minus 1, one at a time, and then the function performs the operations on each input to determine the output. For example, if you plug in x equals 3, again, we would write it like this. Right? If we want to substitute x equals 3 in, we would actually write it like this. We'd go over here, we would replace the x with the 3, and we would get 9 minus 1 is 8. So f of 3 equals 8. So calculate the output for f of x equals 3x minus 1 when the input is x equals 14. That is, find f of 14, right? We don't want to write it like this anymore. Now we want to write it like this. So I'm going to go over here, and I'm going to remove the x and put in a 14, and I'm going to get 42 minus 1 equals 41. So f of 14 equals 41. Now find f of negative 10. And again, f of negative 10, I'm going to go over here I'll give myself a little bit of room. And it equals 3 times negative 10 minus 1, negative 30 minus 1 is negative 31. So f of negative 10 equals negative 31. Now, if the output of the function is 24, what was the input? So now they're saying, what if f of x equals 24? Now, there's a big difference between f of 24 versus f of x equals 24. This one, they're saying, plug in 24 for x and tell me what the output is. This one, they're saying, hey, this is the output, and the output equals 24. So I'm going to go over to this equation. I'm going to take out the f of x, right? It looks like this. F of x equals 3x minus 1. Again, if it was f of 24, I would take this x out and put a 24 in, but it's not. It's asking me, hey, look, the f of x equals 24. So what would be the input that would give you that? So I'll add 1. I get 25 equals 3x. So x would equal 25 over 3. So that would be the input that I would need to put in. That's the input. So f of 25 over 3 would equal 24. Right? That's the input I need to put in to get the output of 24. I hope that makes sense. I know it can be a little bit tricky. Maybe watch that section of the video again if you're still confused, or for sure ask questions. I'll be happy to answer them. Okay, so determine the relationship between f of x, or x and f of x in the equation below. So it looks like, it looks like square roots, right? So the square root of 9 is 3, the square root of 100 is 10, of 4 is 2. Well, this should be 16. 16 square root is 4. Square root of 0 is 0. And then the square root of 20, I don't know, 4 point something, right? So we'll go ahead. I know this isn't a perfect square, so I'll go to my calculator. I get 4.47, about 4.47. So f of x equals the square root of x. That's what I'm plugging in. The x as my input, and I'm getting my f of x as the output. When I plug 49 in, I get a 7 out. When I plug a 0 in, I get a 0 out. All right, we will run along to 136 here. So I think it was 121 was what we were looking at. So there's 36. Now it says, determine the corresponding outputs or inputs for the following functions. If there's no possible output for the given input, explain why. So what happens when I plug negative 3 into this? Well, when I plug negative 3 into this, I get 6 plus 4, I get 10. On this one, when I plug 2 in, again, order of operations say I need to do this first. So 7 squared is 49. 49 times 3, well, I don't know. I know 50 times 3 is 150 minus 3, so I guess it's 147. Here, what number do I need to plug in to get it to multiply by itself 3 times to get 125? Well, how about 5? 5 times 5 is 25. 25 times 5 is 125. Here, I'm going to substitute in a negative 2. Well, what's the square root of a negative? Actually, for now, we're going to say that there's no solution because we can't get a negative of that. But you're going to learn a little bit in integrated 2, and then especially in integrated 3, you're going to work with it. There is an imaginary number called I, which is pretty cool, which is the square root of a negative number. But for now, we don't know that. So we're going to pretend that we don't know I exists. And for now, we're going to say there's no solution. By the way, if you've ever heard a multiple choice or seen a multiple choice where it doesn't say no solution, it says no real solution, that's probably better. There actually is a solution here, but it's an imaginary solution. So we'll just say no real solution, and we'll leave that for your integrated 2 teacher to explain to you. All right, here if I plug 2 in, on top I get 5, and on bottom I get 4 minus 5 is negative 1. So 5 divided by negative 1, I'm going to get a negative 1 out. Here, what number do I plug in to get a 99? Well, it looks like probably 10, right? 10 squared is 100. 100 minus 1 is 99. Here, what number can I plug in to get an absolute value that's negative 3? Well, I can't. This has no solution. And really, even imaginary numbers aren't going to help with this one. Anything that's an absolute value is going to be positive. Remember, absolute value essentially counts steps. There's 3 steps from 3 to 0, and there's 3 steps from negative 3 to 0. But either way, the absolute value is always positive. The only way we would get a negative is we would have to change this equation to put a negative out front, which we're not allowed to do here. On this one, We have 3 to the 4th power, so think about it. 3 times 3 is 9. 9 times 3 is 27. 27 times 3 is 81, so I have a half of 81. So that's just going to be 40.5. And finally, if I plug negative 4 in, the absolute value of negative 4 is 4, and 4 minus 2 equals 2. So went through, some of them we got the output, some of them we got the input, but we were able to work our way through these function machines. And now on to 137, which essentially 137 is saying, hey, look, you can also get answers for this function notation by looking at the graph. And actually, the graph is sometimes easier. So it says, examine the function to find it right. Notice that g of 2 equals 5. That means my input is 2 and my output is 5. So when we go over to 2, 5, you can see right there, hey, look, 2, 5 is on that equation. So we know that g of 2 equals 5. So when the input is 1, what is the output? Well, the input is 1. It looks like I get an output of 1, right? So g of 1 looks like it equals 1. What about g of negative 1? When I look at g of negative 1, when I input negative 1, it looks like I get a negative 2 out. By the way, I'll tell you, this graph's a little bit small. If I'm off by 1 or something, I apologize. What about g of 0? When I substitute 0 into this equation, my output is negative 1. Again, my input is the x-axis, my output is the y-axis. So hopefully this makes sense. Finally, it says, what is the input of this function when the output is negative 2.5? Well, negative 2.5, negative 1, negative 2, negative 2.5 is somewhere over here. It looks like my input would be negative 2, right? So it looks like g of negative 2 equals negative 2.5. Again, C is a little bit different because they gave us the output and they asked for the input. These ones gave us the input and asked for the output. And again, our answer is always going to be on the graph of the shape. At that point, I did want to jump over real quickly and just show you that the notes for 1-2-1 have to do with angle relationships, complementary, supplementary. These ones, corresponding angles and alternate interior angles and vertical angles. These are going to come up in, I think, chapter 7. In a later chapter, I can't remember off the top of my head what chapter it is, we're going to do triangle congruence. And we're going to have to prove things, so we're going to need to know these relationships. So hopefully you guys know these from junior high school, but I did want to point that out in case it's something that you have forgotten.